Good morning. Today what we're going to do is we're going to look at 3B using Pythagoras' theorem in 3 dimensions. Now, so what you're doing is you're going to be imagining what would happen if you're looking for a line that crosses from one corner to another inside a 3-dimensional object. So we'll look at some examples of this and how these are worked and some strategies that you can use to make it a little bit easier for you. But again, remember, your basic mathematics here is simply the Pythagorean formula. Oops, if I can get it right. So keep that in mind as you go and make sure you're labeling. Now, we're going to be working with line segments, so they're usually named as the points at each vertex. So you're going to see that they'll be labeled like line HG, etc. And it's really important that you make sure that you label things correctly so that you can get your A, B, and C in the correct position for use in the formula. These are generally 2-step problems, okay? So keep that in mind. You're generally going to have to use the formula twice because you're going to have 2 unknown links instead of just one where we could just plug in the 2 we knew into the formula and then do the mathematics, do the algebra. But this time, you're usually going to have 2 unknowns, okay? So what we're going to do is just go to the exercises so that you can see these are much easier to do if you visualize them. And I'll be using lots of color, so you might think about using some colored markers or something to help understand which piece goes with which sides, okay? So let's just go to the book. All right. So here in question 1, we have a cube, and it says each side is 3 centimeters. So what you know about a cube is that every side of a cube is always the same length, right? So that means every one of these sides in the cube, including these dotted lines in the back, are all 3 centimeters. Find the lengths correct to 3 decimal places. Now also remember that it is very important that you use the right decimal places or you won't get exactly the same answers, because when you start using these numbers that you've calculated in the formula to find the second triangle length, if you don't use the correct rounding, then it won't work, okay? So the first thing they want you to do is find line AC. And if you look at the drawing, when you're looking at finding AC, AC is a line inside. So if you think about it as the floor of a room, if this was the floor, then this line AC is a line going from one corner of the room to the other corner of the room. And what we know about a cube, or a room supposedly, is that all of these places where the walls meet should form a 90-degree angle. They make a corner, right? And so if that's a 90-degree angle, then what you have here is you have a right triangle. So let's take a look at where that right triangle exists. From AC to CB and to AB. That shape is a right triangle. And if I make a right triangle here, I know the lengths of 2 sides, which will allow me to use Pythagoras' theorem or formula to find the length of this side. Now, again, if this is our right angle, the corner is always the right angle, right? If that corner is the right angle, then that line AC is the line opposite the right angle, which of course is my hypotenuse. So we always call that C. So now I can simply plug it into the formula and do the math. Remember, it's A squared plus B squared equals C squared. Well, I know my A and my B are the legs of the triangle. Doesn't matter which one's which, especially in this case, because they're both the same. And they're going to equal C squared, which is the part that I don't know. So we'll take 3 squared, which is 9, plus 3 squared, which is another 9, equals c squared. Add your 9 plus 9 gives you 18, equals c squared. We need to eliminate that square, and the opposite of a square is the square root. So we'll simply take the square root of both sides, which on this side just leaves me c, and on this side you'll just plug in the square root of 18 into your calculator, and again remember they want it rounded to 3 decimal places. Okay, and after you put the square root of 18 into your calculator, you should get 4.2426, and I took it to 4 decimal places, but they won't, just so that I can round it to 3. That 6 is going to round that 2 up, so you're going to have 4.243 equals your C. So, and of course remember, those are centimeters. Don't forget your units when you're answering your question. All right, so 4.23 centimeters is that line AC. So AC equals 4.243 centimeters. Now that gives you that line. That's that line going across the floor from one corner of the room to the other. But then they're going to ask you the next part, which is to do this line AG. Now, for some of you it's going to be difficult to see that, but if you look at it, AG is simply a right triangle where the bottom of the triangle is that AC line that we just found. The other leg of that triangle is that CG line right here on this side. And so that means that the hypotenuse, or the long slanted side, is the AG line. And that's what we want to find next. So that's what I was saying about finding these, most of these being two-step processes. We had to find this piece first, so this line AC, we had to find that first so that we could then use that information to find the hypotenuse of the bigger triangle that's going through the room. Okay, so here's our right angle. We have our two legs. We know the hypotenuse, so let's just label them. So we can call that one A, this one B, and that one C. I'll plug in the information that you know. We know that our A side, that we're calling it now, is 4.243. We just found that. We know that the GC line is simply one of the sides of the cube, so that's 3 centimeters. And what we don't know is this side. So we're going to be using the same information, the formula in the same way to be able to find that side. We're just, this time, have a different measurement for our middle number. So let's just plug in what we know and do the math. Switch back to black because I almost can't stand it. All right, A squared, so again, that's the number we just found, so 4.243 quantity squared, plus our B squared. Our B is simply one of the sides of the cube, so it's 3, and our C squared is the information we're looking for, so it'll just stay C squared. So we already know that if we square 4.23, all right, you're going to get 18. Now, not exactly 18 because we rounded it to that, but we took the square root of 18 to get that number, so you know it's going to be 18. And 3 squared is simply going to make 9 equals C squared. And that's always going to happen with this number. It's always going to turn back into the number that you had before. 18 plus 9, of course, 27 equals C squared. And then to get rid of the square, we'll take the square root of both sides. That's going to give you C on that side. We'll simply enter our 27 and take the square root of it. That gives us 5.1961. And again, I take it to 4 places because we need to then round it to 3. But that 1 is not going to have any effect on that 6. So it's just 5.196 centimeters. Okay? Therefore, line AG is 5.196 centimeters long. Okay, so it's a matter of finding a right triangle that will work for each value. And remember that every one of those corners of geometric shapes like that will always make a right angle. Now I want to look at one more because it involves a triangle or a pyramid shape, and sometimes that one can give you a little trouble. So let's just go to that one in the book, see if we can find it. Yeah, this one looks a little more complex, but it's not. You're just finding triangles using the lines given. So just try to visualize it one piece at a time. Okay. So let's just go back to the section example that they do a good example of. One of them using a pyramid. So it's here. For the square pyramid shown in this diagram, calculate the length of AC correct to 2 decimal places. Well, here AC is another one of those lines that's just going straight across the pyramid. Okay, so therefore we know that that side, that since the bottom is a perfect square with lengths of 25 centimeters, we know AB and BC are the legs of a triangle, with the hypotenuse being the line AC. So we could simply do our math. They use AC, AB, etc. You don't have to. And you end up with 35.355 for that length, right? Again, simply using the theorem and the line going across. Then the next thing they want you to do is they want you to find the length of line EF. Well, EF is simply a straight line that intersects with the bottom of the pyramid, and so if they intersect at a corner there, that's creating a right angle. But it's a right angle using AC as the leg, but this time you're not going to use the entire AC because this line is hitting it at F, which is right in the middle of the line. So what you're going to have to do is you're going to have to divide AC by 2, divide it in half, and then that AF length will be one of your legs. Okay? Right? Then we already know this long side, so we know the hypotenuse is 26. So what we're looking for is this height from the bottom of the pyramid to the top, so that line EF. Okay? So you're looking for EF. We know that the slanted side of the pyramid, that side is 26. We've just found the whole length, AC. FC is just simply half of that, so you can see that's where they're dividing by 2. So they simply divide it by 2 and round it again to 3 decimal places. Round to 3 decimal places every time. Then plugged it into the formula, took the square root, and ended up with 19.006, or 066, sorry. So just visualize a triangle and what sides that you would need in order to make that work. All right, so you have some exercises written in your exercise list, so you know exactly what numbers to do. But I'll put them here in the video. Okay, so here are your exercises. You're going to do questions 1, 2, 6, and 8. Remember to check your work as you go so that you make sure that you're on the right path, because sometimes these can be a little tricky. All right, thanks, gentlemen. See you next time.